and this incident light is parallel to principal axis, and this is pole. This is pole. This is center of curvature. This is pole, and what is pole? Pole is the middle point of the mirror, and line joining the center of curvature and pole is the principal axis. So this line is the principal axis, and this is polishing of the mirror. Okay, so see what happened, what is happening. So this is the ray of light, and this ray of light is parallel to the principal axis. If a ray of light is parallel to the principal axis and principal axis of a convex mirror, earlier you have seen in case of a concave mirror, if a ray of light is parallel to the principal axis of the concave mirror, this is a concave mirror, it passes from the focus after reflection. Here reflection is taking place, and after reflection it is passing from the focus. Now for the convex mirror, ray of light is parallel. Okay, ray of light is parallel to the principal axis. Now okay, this ray of light will reflect like this, and when you will produce this reflected light in the backward direction, you have produced this reflected light in backward direction. So incident ray, reflected ray, this reflected ray you have produced in the backward direction, and this point where this ray will meet to the principal axis will be a focus. So what can you say? You can say that it is looking like that, it is appearing that the reflected ray, this is the ray which is coming towards the mirror is a incident ray, and the ray which is going away from the mirror is a reflected ray. This is reflected ray, and which ray is this? Incident ray. This is principal axis. What is P? P is pole. What is F? F is focus. What is C? C is center of curvature. So first rule for the convex mirror is a ray of light incident parallelly on the convex mirror is reflected back, and when it will produce backward, it will meet to the focus on the principal axis. It will meet to the focus on the principal axis. Remember this point. This is for the convex mirror. Hello, Nawal.
Yes, sir.
Okay, so we are discussing in the last class we have just completed this image formation by the concave mirror. So after that we are discussing now rules for image formation by the convex mirror. So for the convex mirror, first rule is this: when a ray of light is uh, parallel to the principal axis of a convex mirror. So after reflection, this is the reflected ray. After reflection, when the reflected ray is produced backward, it will meet to the focus on the principal axis like this. This is the first rule. Second, if a ray of light is going towards the focus, if a ray of light is going towards the focus, it is going towards the focus. Okay. after reflection it will become parallel to the principal axis. Here what is happening? A ray of light is parallel to the principal axis. After reflection, it is appeared to us that the reflected light is coming from the focus. But this is just the reverse case. Here, if a ray of light is going toward the focus, after reflection, it will become parallel to the principal axis. So after reflection, here at this point, the reflection will take place. So after reflection, it will become parallel to the principal axis. Third rule, if a ray of light is going towards the center of curvature of a convex mirror, remember this is a convex mirror, so what will happen? It will retrace its path. Why it will retrace its path? When you will draw the normal, so normal will also pass from the center of curvature, so angle of incidence equal to 0 in this case, and angle of reflection also equal to 0. That is why this ray of light will retrace its path. These are the three rules. Okay, in case of the convex mirror. Now we will discuss the image formation by the convex mirror. Image formation by the convex mirror. So in convex mirror, there are only two conditions of object can be placed either at infinity or either it can be placed between the mirror and the infinity. So first case I am taking object at any position except infinity. So you can place object at any position. For example, you are taking an object and this is the object you have placed here. This is a object, and this object suppose giving a light of green color. Okay, so this is the object, and this object is placed between the infinity and the mirror, or you can say uh, between the pole and the infinity. You can say here the object is placed. Now for the image formation, what we do? There is a requirement of two rays. There is a requirement of two rays from the object. So this is the object. So first ray from the object like this. This is the incident ray. This is the first incident ray by the object. What will happen now? We know that this will happen. After reflection, it will appear that this ray is coming from focus. Now another ray. You know that when a ray of light in case of a convex mirror or in case of a concave mirror is going toward the center of curvature, so what happen? It will retrace its path. So it will retrace its path, and when you will produce both these refracted rays, not the reflected rays, so both these rays will meet here once again. This is the first incident ray from the object, and this is parallel to the principal axis. And when a ray is parallel to the principal axis, so it will reflect it like this. After reflection, when you will produce this ray backward, it will meet to the focus. Okay, another ray which is going toward the center of curvature, here reflection will take place in between because there is a mirror. So after reflection it will retrace its path. So if it will retrace its path, so this ray will go in this direction. Like this. This ray can go like this. Now you can see this is the reflected ray, this is also the reflected ray. Both the reflected rays in this case are diverging rays, and diverging rays will never meet. So what we will do, we will produce these diverging rays in the backward direction, and somewhere here these rays will meet and you will get the image. So this will be the image of the object. This will be the image. Now we will see the position of the image, nature of the image, size of the image, magnification of the image. Now you can see this image is formed in the mirror. Or you this image is formed in the mirror. Now you can see size of the image. So this is the object. This is the object and this is the image. So size of the image is less than the object. Or you can say height of the image is less than the height of the object. Now you can see here rays are not actually meeting. Rays are not actually meeting. These rays are just appearing to meet at a point. So which type of image we will get? Real, not the real, virtual image we will get. And virtual image is also erect image. I have told you, virtual and erect image we will get smaller than the object in the mirror. So all, and magnification, how magnification will be there? So image is formed always behind the mirror. Virtual and erect. Why the virtual and erect? Because the rays are appearing to meet. Reflected rays, you can say. Reflected rays appears to meet you can say reflected rays when produced backward appears to meet. That is why we are getting virtual image and erect also. Diminished means you can see here size of the image is small as compared to the object. So you can say image is smaller than object. Smaller than object. What is the meaning of smaller than object? Height of the image is smaller than the height of the object. So what will be the sign of magnification? First we will see. Sign of magnification here. Will the magnification will be positive or negative? We will see. So what is magnification? Magnification is height of the image divided by height of the object. So above the principal axis, we take the positive uh, distance. Below the principal axis, we take the negative distance. So this image is above the principal axis. So sign of the height of the image will be positive. Sign of the height of the object will also be positive. So you can say that you will have here positive and you will have here positive. Finally, the magnification you will get positive magnification you will get. So remember, for virtual and erect image, the magnification will be positive. Now magnitude of the magnification. Magnitude, for the magnitude of the magnification, we know that we will apply mod height of the image, height of the object. In this case, height of the object is greater than the height of the image. Means this value is greater than this value. Means this value must be less than 1. If I am writing 5 divided by 10, denominator is greater than the numerator, then this value will always be less than 1. So you can say the magnitude of the magnification is less than 1. So what is mod m? Magnitude of magnification. Magnitude of magnification. Now there is one case when the object is at infinity where the image will form. So this is very simple case we will discuss object at infinity. So we know that when the object at infinity, from the object and at infinity, rays are parallel rays from object at infinite, parallel rays from object at infinity. In infinity means the object is very far from us. Okay, so these are the rays from the uh, object, and object is at infinity. So what will happen? This ray is parallel to the principal axis, so after reflection it will appear to be coming from the focus. So you can draw the image. After reflection it will coming toward the focus. Okay, so this is the parallel ray and to the principal axis, reflected ray, and you have produced this reflected ray in backward direction, meet at focus. Same is the case for this, and both the rays will appear to meet at focus and image will form at focus, and image will be visual and erect, and point size image you will get. Size of the image will be very small. So image is formed at focus, virtual and erect. Erect, you can say for erect, you can say upright also. So highly diminished means point size, magnification will be positive, and magnitude of the magnification very less than 1. Upright means if the object is like this, image should also be like this. So this is the upright or erect image. This is the point. As the object moves far from the convex mirror, image moves towards the focus and becoming smaller. Now your object is here right now. Now if you will move this object far from the mirror, so what will happen with the image? This image will move towards the focus and it will become smaller in size. Okay, so this is written here. Okay, all of you take the screenshots. Matthew, Nawal and Nafisa, all of you, please take the screenshots.
Yes, sir, finish.
Taken, Matthew and Nawal?
Yes, sir.
Yes, sir.
Yes, sir, taken.
Okay. In 10th class also you have studied this image formation by the concave and convex mirror.
Yes, sir, taken.
Taken.
Yes, sir.
Okay, after this we will discuss mirror formula. There is a formula known as the mirror formula, And mirror formula is the relation between the focal length of the mirror, image distance of the mirror, image distance means the distance of a pole from the image, or distance of an image from the pole, and object distance. So mirror formula is nothing but you can write. Okay, take this screenshot also. Okay. So mirror formula is, you all know, I think, mirror formula 1 upon focal length of the spherical mirror is equal to 1 upon V plus 1 upon U. F is the focal length, V is the image distance, and we know distance is measured from the pole. U is the object distance. But today we will derive this formula, how this formula comes. In 10th class, you have only this formula, not the derivation. So mirror formula, this is the mirror formula. Focal length, image distance, object distance. Now we will do derivation. How this will come. For this derivation, there are certain assumptions. For this derivation, there are certain assumptions. What are those assumptions? In the starting, I have told you that in our syllabus, or mostly we will study the mirrors of small aperture. This is the assumption. Mirror of small aperture. And we know that for the mirror of small aperture, focal length is equal to r by 2. In actual, the focal length is given by r minus r by 2 sec theta. But for the small aperture, this theta becomes very small. Or you can say approaching to 0. That is why this sec theta becomes 1. So focal length becomes r minus r by 2. R minus r by 2 is again r by 2. Okay. So you can just say that this mirror has very small aperture. This mirror is small aperture, very small mirror. This is okay. So this is the object place. This is the object here. And from this object, and somewhere here will be center of curvature. Suppose here is the center of curvature of this mirror. This is the concave mirror I am taking. I am just driving this formula with the help of concave mirror. This can be derived with the help of convex mirror also. This is pole, this is center of curvature, this is the object. Now, from this object, a ray of light is going in this direction, like this. And as this ray of light is passing from the center of curvature, so it will appear, it will retrace its path. So going like this and coming like this, simply. So this ray is coming like this. Why? Because this is passing from the center of curvature. Now another ray of light from this object, because we know that for the image formation, there is a requirement of at least 2 rays. So another ray of light from the object, suppose like this, at this point, incident at this point. Okay. So Ray of light from the object is going like this, striking on the mirror, and reflection will takes place. Now, if the reflection is taking place, so there is a requirement of normal to define the angle of incidence and the angle of reflection. So normal always passes from the center of curvature of a spherical mirror. So this will be normal. This will be the normal. Okay, so if this will be the normal, suppose this angle of incidence I am taking theta. So angle of incidence will be equal to the angle of reflection. So accordingly, the reflection will take place. So after reflection, suppose this ray is going like this. So and this angle will be theta. Why? Because this is the angle of incidence. This is the angle of reflection. And now you can see there is one reflected ray. This is the reflected ray. This reflected ray is coming in this direction like this, and this reflected ray is coming in this direction. Both these rays will meet at this point. So here the image will form. Here the image will form. Okay. After that, object is placed here, and this is pole. So we will see what is object distance and how we will represent that. So I told you in the sign convention that all the distance you will measure from the pole. So and with sign you have to take the distances. So now from the pole you are measuring the distance, and this is your object distance u. Object distance u is the object distance na? And this you are measuring, now you can see this is the direction of the incident light, and you are measuring the distance in the opposite direction of the incident light. It means you will take this u as negative. It means you will take this u as negative. So this u you will take negative. So you can take this as minus u. Why I am taking this minus u? Because I am just measuring the distance from the pole. An object is here, and I am measuring the distance in the opposite direction of the light, incident light. That is why the distance is negative. And this is the image. This is the image. So image distance will also be measured from the pole. So you can say that image distance will be this. This will be the image distance u. Sorry, v. V will be the image distance. So this v will be also minus v, because you are measuring the image distance in the this direction, opposite direction of incident. Now distance between the pole and the center of curvature is the radius of curvature. Distance between the pole and the center of curvature is radius of curvature. So talking about this distance is minus r. Again you are measuring distance in this direction, that is why this is minus r. Okay. This point suppose is m point. Which point is this? M. From this m point on the principal axis I am just drawing a perpendicular. This is the perpendicular. Perpendicular means this angle is 90 degree and this angle will also be 90 degree. This angle will be 90 degree. This is perpendicular, and this perpendicular is suppose this point is p dash. This point is p dash. Now there is one more assumption. Assumption. If the aperture of this mirror is very small, so this p dash and p will be very close. Aperture if very small, this p and p dash will be very close. Okay, like this you can see. If aperture it becomes very small, so this distance is decreasing now. Distance between p and p dash is decreasing. Now the distance is increasing. So if aperture is small, then the distance between P and P dash will be very small. So you can say that the distance P and P dash is very small, or you can say P dash is tending to P, or you can say P dash and P distance is very small. So it means that if this P and P dash are just same point, you can see now. So you can also say this IP dash is equal to IP. You can say that now this IP dash is equal to IP. So you can say that IP dash is equal to IP. What is IP? IP is minus V. You can say CP dash is equal to CP. CP dash is equal to CP. And what is CP dash is equal to minus R. You can say OP dash is equal to OP. OP dash is equal to OP. And what is OP? OP is minus U. So remember this point. Now you can take this triangle first, OMP dash, triangle OMP dash. So now see in triangle OMP dash, in triangle OMP dash, we will use little bit of trigonometry here. So in this triangle, this is a right angle triangle. OMP dash is a right angle triangle, and suppose this angle is alpha, this angle is beta, and this angle is gamma. This angle is alpha, this angle is beta, and this angle is gamma. So from the triangle OMP dash, I am finding tan alpha. What will be tan alpha? Tan alpha will be MP dash divided by OP dash, because tan is perpendicular of the triangle divided by the base of the triangle. It will be MP dash divided by OP dash. What is MP dash? MP dash, you can take H. So MP dash I have taken H, and this H will be positive because this height is above the principal axis. So it will be plus H divided by, what is OP dash? OP dash is minus U. So this is in minus. Okay. After that, you can take this triangle CMP dash. So in triangle CMP dash, this angle you can find. See this triangle CMP dash. So tan gamma is equal to MP dash divided by CP dash. Tan gamma MP dash divided by CP dash. What is MP dash? H plus H. What is CP dash? CP dash is minus R. Okay. There is one more triangle, this triangle IMP dash. IMP dash. So in triangle IMP dash, we can write MP dash divided by IP dash, tan beta. In triangle IMP dash. In triangle IMP dash, tan beta we can find plus H divided by, I am writing directly now, plus H divided by this distance IP dash. And what is IP dash? IP dash is minus B. IP dash is minus B. So you can write it as minus B. Now again this assumption, aperture is very small, so alpha, beta, gamma are very small. Due to this assumption, mirror is of small aperture, so you can say that focal length is this, and you can also say that alpha, beta and gamma are very small. Okay, alpha, beta, gamma, these angles become very small when the aperture of the mirror will be small. So if these angles are very small, so for this 10 alpha, 10 alpha can be written as this 10 alpha, na? This 10 alpha can be written as alpha. So this 10 alpha can be approximately written as alpha. Okay. So this instead of this 10 alpha, why this is happening? Because this alpha is very small. So for a small angle, 10 of theta can be written as theta. So this 10 alpha can be written as alpha. So it will become alpha is equal to plus h divided by minus u. This is equation number 1. Similarly, you can write for 10 gamma. So 10 gamma can be written as gamma. So you can write gamma is equal to plus h by minus r. You can write for 10 beta also. So 10 beta can be written as 10 of beta approximately equal to beta, and beta can be written as, this is equation number 2, beta can be written as plus h minus v. This is equation number 3. Okay, again see this triangle OMC, triangle OMC, triangle OMC. This gamma is the exterior angle of triangle OMC, and alpha and theta are the interior angle. So sum of the interior angle is equal to the exterior angle. So we can write alpha plus theta is equal to gamma from triangle OMC. Triangle OMC, we can write alpha plus theta is equal to gamma. This is equation number 4. Alpha plus theta is equal to, now see this triangle CMI, CMI. So for CMI triangle, this beta is the exterior angle, beta is the exterior angle, and gamma and theta are the interior angle. So we can write beta is equal to gamma plus theta. In triangle, what type of triangle is this? CMI, triangle CMI. What you can write? You can write gamma plus theta is equal to beta. Gamma plus theta, gamma plus theta is equal to beta. This is equation number 5. And for in this triangle, gamma is exterior angle, and in this triangle, beta is exterior angle. Beta is exterior angle. And there is one information here. Exterior angle is equal to sum of interior angle. Sum of interior. Sum of interior angles. So this concept we have used there. Now we have 5 equations. First we will solve equation number 4 and 5. Add the equation number 4 and 5. Add 4 plus 5. What you will get? No. Subtract equation number 4 and 4 from 5. Not add. Subtract. 4 minus 5. So what it will become? This is alpha plus theta, and subtraction is taking place, gamma plus theta, and here you can write gamma minus beta. So it will become alpha plus theta minus gamma minus theta is equal to gamma minus beta. So theta and theta cancel out. So you will have alpha plus minus gamma. Alpha minus gamma is equal to gamma minus beta. So what can you write? This, you can write this gamma and oh, actually just a minute. Gamma minus beta. It will be minus gamma. Huh. Fine, it's fine. This is alpha, na? So you can write alpha plus beta is equal to gamma plus gamma. It will become 2 times of gamma. Now what are the values of alpha, beta and gamma? This is alpha and this is gamma. Where is gamma? This is gamma and this is beta. So put the value in this equation. Suppose this is equation number 6. Put alpha, beta and gamma. Put alpha, beta and gamma. So alpha is what is alpha? Where is alpha? Plus h divided by minus u. So in this equation, alpha is plus h by minus u. Beta is plus h divided by minus v. Gamma is 2 times of gamma is plus h divided by minus r. Now this h is gone. Minus is gone. You will have 1 by u plus 1 by v is equal to 2 by r. And we know that focal length is equal to radius by 2 for the small aperture. So we can write 2 by r is equal to 1 by f. So this 2 by r can be written as 1 by f. So you will have the formula 1 upon v plus 1 upon u is equal to 1 upon f. So you can just write 1 upon u plus 1 upon u also, 1 upon v also. So final formula. So okay, take the screenshots.
Done, sir.
Done. So Matthew, have you understood what happened here?
Yes, sir. We are mostly using like the maths proofs we learned in
Yeah,
like
of course,
ninth.
of course. Actually, na, in derivation, always remember, in any derivation, any type of derivation you are doing in physics, math will always use, and 80% math will use. See in here in this question, where we have used physics, where this is total mathematics. We have used just the sign convention only, and this approximation only. Remember that this formula is not valid when the aperture of the mirror is very small. Why? Because this formula is based on these assumptions. If these assumptions will not work, we cannot use this formula. Okay, so have you taken the screenshots? Now take this screenshot. Done?
Yes, sir.
Okay.
Yes, sir. Done.
Done. Okay. So practice this at least 2 times. After this, we will discuss the magnification again. Magnification, you know, is equal to magnification is for the definition. If someone is asking what is magnification, you will say magnification is the ratio of height of the image divided by the height of the object. So what is magnification? And we are talking about the magnification. We have the transverse or linear magnification. There is one more angular magnification that we are not discussing. So magnification is height of the image divided by height of the object. So it is height of image divided by height of object. This magnification is also given by minus of image distance v divided by u. Very important. So I am not driving this. Similar with the similarity of triangle, we can also drive this equal to this. So magnification is this, and we know that height above the principal axis is positive, height below the principal axis is negative if this is the object, and if height above the principal axis is like this, object is placed like this, so it will taken as positive. If suppose the image is formed like this, so it will taken as negative according to the sign convention. Okay. Now we will discuss in magnification. First case, if suppose the uh, magnification is positive, what the positive magnification indicates? Okay, see, positive magnification. What is, first write the formula of the magnification. Height of image divided by height of object. For the magnification to be positive, for this m to be positive, this height of image and height of object should be positive. This should be positive and this should also be positive. So you can say that height of image positive, height of image positive. Okay, means this is the principal axis and this is the object, and image is also formed like this. It's the image. That is why this distance is positive, this distance is positive, and you are getting the positive magnification. So what the positive magnification indicates? This, see the image is erect, and erect image is virtual also. So magnification is positive, so you can say there is an image of virtual and erect image. If magnification is positive, then image is virtual and erect. Second case, if the magnification is negative, negative. So negative means uh, magnification is equal to height of image divided by height of object, and for negative, height of image, sine of height of image and sine of height of object must be opposite sign. Okay, so you can say that sine of hi and ho must be opposite sign. For example, you can take, this is the principal axis and your object is like this, and this is the object, and uh, you will take this height as positive, and image is formed like this. This condition is valid here, and image is this distance you will take negative, and this is the image. So now you can see here this image is inverted image, and inverted image is real also. So we will get the real and inverted image when the magnification is negative. Real and inverted image. Third point, if the magnification is greater than 1, If the magnification greater than 1. What is the meaning of magnification greater than 1? If I am saying magnification is equal to -3, will it be greater than 1 or less than 1? That is why we take modulus of magnification. So modulus of 3 when you will do, so it will become only 3. So sign will never decide the magnification. Okay, means the magnitude of magnification. Magnitude of the magnification is magnitude of magnification. If it will be -3, so you can say that the height of the image is greater than the height of the object. So if magnification is, that is why we write mod of magnification is greater than 1. Mod of magnification is greater than 1 means, how can I write mod of magnification? Mod of height of image divided by mod of height of object. So I can write this at height of image mod and height of object mod greater than 1. So you can say that height of image greater than height of object. If height of image greater than height of object means image is magnified. Image is magnified. So image is magnified. Number 4, if magnification is less than 1. Magnification less than 1. So you can say that height of image will be less than height of object. So height of image is less. So you can say image is diminished or smaller than the size of the object. Image is diminished. For example, if I am saying magnification is equal to -5. So what can you say about the image? If magnification is given as -5, what can we say about the image? So first of all, we will check the sign of the magnification. So this magnification is negative. So what does the negative magnification means? What is the negative magnification means? Real and inverted image. Real and inverted image. And what is the magnitude of magnification? Greater than 1 or less than 1? Greater than 1. Mod of -5 will be greater than 1 because 5 is greater than 1. Mod of -5 will be 5. Mod of -5 will be 5. So if magnification is greater than 1, what can you say? The image is magnified. So you can tell the characteristics of image when your magnification is given. So in this case, the image is real and inverted and magnified. For example, if magnification is 0. Plus 0.75 plus
Be diminished.
0.75. Yeah. So what you will first you will check the sign. So magnification is positive. Positive means the image is virtual and erect. Virtual and erect. Then you will check the magnitude of the magnification. Magnitude of the magnification is less than 1. So if less than 1, then the image will be diminished. Okay. Okay, so take the screenshot. Taken? Matthew, Nafisa, Nawal.
Yes.
Yes, sir.
Okay.
Yes. Yes, sir. Taken.
Okay. Okay.
Yes, sir.
Okay. So do not learn anything directly until and unless it is required. You have to apply your mind why it is happening. If someone is saying magnification is less than 1, if someone is okay, take this screenshot. If someone is saying magnification is less than 1, So first thing, what is magnification? First think what is magnification. You know, magnification is height of the image divided by height of the object is less than 1, means height of the image should be less than the height of object. If height of image is less, connect the dots. If height of image is less, means image is diminished. If someone is saying magnification is negative means sign should be opposite. So sign should be opposite. So if the height of the object is positive, take the case height of the object positive, height of the image negative. So if height is negative, then height of the image is negative, means the image is formed below the principal axis, and below the principal axis height of the image is negative, and below the principal axis what happens when the image forms? It will be inverted. If the image is inverted, it will be real also. So you can say if the magnification is negative, the image is real and inverted. So in this way you have to think. Now we will solve this numerical. So in this numerical they are saying find the position. First thing is position. After that they are asking size. Size means height. After that they are asking nature. Position means from the pole at how much distance the image is formed. And size means what is the height of the image. Nature means will the image is real or will the image is virtual or will it erect or inverted. So find the position, size and nature of an image formed by a concave mirror. So here concave mirror is given. Of focal length given, focal length 10 centimeter. When an object of 2 centimeter long, is kept in front of it, at a distance of A, 15 centimeter. First we are placing the object at a distance of 15 centimeter, then we are placing the object at a distance of 5 centimeter. Okay, so I will solve this question with the help of diagram. Each and everything will be clear from the diagram. This is a concave mirror, and principal axis, concave mirror, and this is principal axis, and this here will be pole. Here is the pole, and suppose the object is placed, they are saying object is placed in front of the mirror. What is the front of the mirror? This is the front of the mirror, this is the back of the mirror. Here the object is placed, suppose here, this is the object. Object is placed at a distance of 15 centimeter. So this distance is 15. Okay, this distance is 15 centimeter. Okay, no problem. Focal length is given. We know that the focal length of the concave mirror is negative. So that is why focal length is minus 10 centimeter. Finish. Now this object distance, we will measure the object distance from the pole, and this object will give the light in this direction. This is the light, and you will measure the distance from the pole in this direction. So object distance you will take negative, minus 15 centimeter. Now you can find the image distance with the mirror formula. We know that what is mirror formula? 1 upon f is equal to 1 upon v plus 1 upon u. 1 upon f, 1 upon minus 10 is equal to 1 upon v. So we will not put any sign for v because this value is unknown. Automatically with answer there will be sign. It will be positive or negative. It can be positive or negative. So plus 1 upon u is minus 15 centimeter. So now we can solve it easily. So it is 1 by v is equal to, it is 1 by 15 minus 1 by 10. So take the LCM. Okay. So 15 2s and 3s. It is minus 1 by 30. So 1 upon V is minus 1 by 30. So V you are getting minus 30 centimeter. Now what is V? V is the image distance. V is the image distance from pole, na? From pole we take, and this is, you can say, also the position of the image. Position of image. Now and this sign is negative. This sign is negative. Negative sign means you are measuring the distance of the image from the pole in the opposite direction of the incident light at a distance of 30 centimeter. So suppose here will be the image. I don't know that this time the image is real or virtual. So image will be somewhere here at a distance of 30 centimeter in this direction. Means in front of the mirror, you can say, because from this sign it is clear that the mirror, the image will be in front of the mirror. Why? Because you have to go in this direction to measure the distance of the image. So here, somewhere here will be image. Okay, now position we have find it out. After that we have to find the size of the image. So size of the image, size can be find with the help of the magnification. So we know magnification is equal to height of the image divided by height of the object. This is also given minus b by u. So we have only height of the object, not height of the image. And height of the object is 2 centimeter. So height of the object you will take positive. Why? Because this is above the principal axis. So height of the object is given as plus 2 centimeter. Remember. Now equate this relation. Or first find the magnification by this minus b by u, and whatever you want, what means whatever the way you want to solve. So I will write it as height of image divided by height of object. So height of image we want to find. We will not put any sign for height of image because this is the unknown thing. Height of the object is plus 2. So minus, now we know what is the position of the image, and with sign we will put minus 30. And what is object distance? Minus 15. Object distance u is minus 15. So you will put here is minus 15. So height of image you will get 15 to the, okay, and this minus and minus will be cancel out. 15 to the 2, here will be 2. This will be cancel out, here will be 2, plus 2 and 2 is equal to 4. So here you will get, there is one more minus sign. So here you are, height of the image you are getting minus 4 centimeter. What this minus sign indicating? Height of the image is negative means the image is formed below the principal axis. So somewhere here the image will form, and this image will be inverted image. Now it is clear. What is the height of the image? 4 centimeter. Now you can say this image is inverted and it is real also. So you can say the image is real and inverted. In this way you can, now it is clear, image is inverted. But there is one more way to solve. This is the height of the image, or you can say size or height of image. If you want to find without the diagram, nature and all the thing, so what you will do, magnification is in minus 4 you have. Now this magnification is minus 4, so magnification is negative. Negative magnification means image will be real and inverted. Clear? And okay, magnification is real and inverted, and magnification, magnitude of magnification is greater than 1. So you can say height of the image is greater than the height of the object, or you can say size of the image is enlarged or magnified image. Okay, so in this way you have to solve the question. Okay, take the screenshot.
Yes, sir. Take it.
Hmm. So reflection is finished here. Okay. So in reflection, light is moving in the same medium again and again. But in case of refraction, what will happen when the light goes from one medium to another medium? Suppose
Yes,
the
sir.
light is
Finish.
okay, fine. When the light is going from one medium to another medium, suppose the light is going from air to water. So when the light goes from air to water, one thing you have to remember, in different medium, the speed of light is different. So in water, the speed of light will be somewhat less than air. So due to that, there is a bending of light, and that bending of light is known as the refraction of light. Refraction of light. So for defining the refraction and for the study of the refraction, there should be the understanding of the what is the optical density and what is the refractive index. So in the refraction of light, so refraction of light, bending of light rays when it passes from one medium to another. Suppose this is medium one. You can suppose this is a air medium, water, anything you can assume. Here is a medium two, and this is the interface separating two medium. This is a ray of light. This is a ray of light. This is the incident ray, and this ray of light. Uh, this is the interface. Here the refraction is taking place. Refraction means bending of light is taking place. Okay, so this is known as the refraction, bending of light rays when it passes from one medium to another, and this is the normal. Normal we know from the reflection. This will make an angle of 90 degree with the surface. So now we will define denser and rarer medium. So there are two types of medium, denser and rarer medium. So I have defined here optically denser medium. A denser medium is that medium in which the speed of light is more as compared to other medium. Optically rarer medium in which the speed of light is faster. And now the thing that defines the which medium will be denser and which medium will be rarer is the optical density. There is one more density in 11th class. I think you have studied that density known as the mass density. Mass divided by volume is known as the density. Simply we say density. Okay. So here is the optical density. So optical density is uh, decides which medium will be rarer and which medium will be denser. So if the optical density is more of any medium as compared to the another medium, then you can say that that medium is a uh, denser medium. And how we find that optical density is greater? So there is a term refractive index. There is a term refractive index. So this refractive index will decide the optical density. So refractive index will be the measure of optical density. So we will study the refractive index. Okay. So why we are studying the refractive index? Refractive index tells us the there are many things with the help of refractive index we can just tell. Okay, later I will tell you. Okay, take the screenshot.
Yes, sir, taken.
So Nafisa, do you have any doubt regarding this? Okay, one more thing I have not explained. This is the path of the light ray if there is no medium. So if there is no medium, light goes straight. If in between there is a medium, there is a bending of light. Okay. So after this, we will discuss the refractive index. So refractive index, if someone is saying refractive index, so refractive index is the ratio of the speed of light in air, vacuum or free space divided by the speed of light in that medium. So next topic is the refractive index. So refractive index is represented by mu, and refractive index is basically the C by V. What is C? Speed of light in vacuum. And what is V? Speed of light in medium. And mu is the refractive index of the medium. So this formula, okay. And refractive index is always greater than 1. Why? Because speed of light in air is maximum. Okay, speed of light in air is maximum than any other medium. That is 3 into 10 to the power 8 meter per second. Speed of light in air. C. C is known as the speed of light in air. 3 into 10 to the power 8 meter per second. So there is a theory given by the Albert Einstein theory of relativity. According to that, nothing can travel faster than the speed of light. So speed of light in medium will change, but uh, this speed is the maximum speed of light in medium. And refractive index is greater than 1. Why? Because the C will be always greater than B. And one more thing, if the refractive index will increase of any medium, for example, take the example of air and water. So the refractive index of air is 1. Refractive index of air is 1 and refractive index of water is greater than 1. So you will see there the speed of light in water is less as compared to the air. So if the refractive index will increase, then the velocity of light will decrease. So refractive index of air 1. Why 1? Because when you will calculate the refractive index of air, so C is there and here also it will be C, because then you will take speed of light in air. So C by C is 1. For example, refractive index of diamond is 2.4. It is given. It is given that refractive index of diamond. We know diamond. So refractive index of diamond is 2.4 is given. What is the refractive index? Speed of light C by V. Speed of light in air divided by speed of light in diamond. Now you can write it, and D is representing the diamond. Oh, not this is G I have written. So D is representing the diamond. Okay. So we can write 2.4 is equal to C by VD, and VD can be written as speed of light in diamond. VD means speed of light in diamond is equal to C divided by 2.4. So you can see here refractive index 2.4 represents that the speed of light in diamond is 1 upon 2.4 times of speed of light in air. Okay, so this is the speed of light in diamond. Speed of light in diamond. Okay. Okay, this is medium 1 and this is medium 2, and a ray of light, this is the incident ray, and this is the refracted ray. This is the incident ray, this is the medium 1, this is the medium 2. Light is traveling, and now no need of this. Okay. This is the medium 1, and this medium have the refractive index, suppose mu1, and this medium has the refractive index, suppose mu2, and speed of light in this medium is suppose v1, and speed of light in this medium is suppose v2. Wavelength of light in this medium is suppose lambda 1, wavelength of light in this medium is suppose lambda 2. What is mu? Is the refractive index. What is lambda? Wavelength of light. What is v? Speed of light. So there is a relation. There is a relation. We know that more will be the refractive index, less will be the speed. So you can write refractive index is inversely proportional to 1 by v. Speed will increase, refract, or you can say more refractive index, less speed of light. So from this you can write a relation. You can write a relation mu2 divided by mu1 is equal to v1 divided by v2. This relation will be valid. And during the refraction, frequency remains same. During refraction, frequency of light remains same. And you will ask why, sir, frequency of light will remain same, but wavelength is changing. Wavelength changes. So this can be explained in two ways. So I will explain like that. This light is coming from some source, and the source is a specific kind of source. So basically, frequency is depending upon the source. So that is why here the source is not changing. That is why the frequency is not changing. This ray of light is coming from sun, can be from any object. That is why the frequency is not changing. So this ratio v1 by v2, v1 by v2, there is a relation that you should know. The relation between the speed of a wave, light is also a wave. So there is a relation between the speed of wave and the frequency and the wavelength. So speed of the wave is equal to frequency times wavelength. What is v? Speed of light wave. Light is also the electromagnetic wave. F is the frequency of wave. Light is also wave. Lambda is the wavelength. So speed of a wave is equal to frequency into lambda. So this formula we will use here. So v1 by v2, you can write during the refraction frequency is same. So you will write frequency into lambda 1 and frequency into lambda 2. So v1 by v2 can be written as lambda 1 by lambda 2. So you can write here lambda 1 by lambda 2. This relation will be followed during the reflection, and take the screenshot, and rest of the topic we will discuss in the next class. Refraction means when a light is traveling from one medium to another, bending of light will take place. If you have any doubt, then you can ask me. Matthew, do you have any doubt?
No, sir, no doubt. So next class we'll
And
do refraction, right?
of course, in next class we will
Yeah,
do the
okay.
refraction. And because diffraction is just bigger than means in terms of this topic, you can say in refraction there is more content. We have to study various things. We will study in refraction in the last lab. We will study real depth and apparent depth. So you have seen sometimes in a tank when there is any object inside the water. So it seems the object seems a little bit higher. I think you have observed or not, I don't know, but it happened. So
Yeah,
basically,
even when you look from below the pool as well, it
yeah,
looks
yeah.
more higher.
So that is happening now because of the refraction, and those things we will discuss in the next class, and why those things are happening. Okay, so don't miss the classes.
Okay,
I will
sir.
just giving that advice you means because refraction is means reflection is easy as compared to refraction. Taken the screenshots? Done?
Yes, sir.
Okay. So this relation, remember, we'll solve one or two numerical on this relation. What is mu? Is the refractive index of the medium. Okay, completed all of you?
Yes, sir.
Yes.
Okay, so basically today we have done the refractive index and some of the reflection. And in the next lecture, I am telling you, next lecture is going to be very important because there we will study the real depth and apparent depth and lateral shift due to a glass slab, and that those topics are confusing. I know why those phenomena are happening, and there we will draw the ray diagrams. Okay, so